So we're going to look at solving linear equations, and we'll go over a few examples and go over the process on how we solve linear equations. So let's look at an example. Let's just say if I had x plus 4 equals 10, right? And I want to solve for x. So the way I'd solve for x is I need to get rid of this plus 4 on the left-hand side and take it to the right-hand side. So I'll write it down. So this is my left-hand side, and I've got the equals, and this is my right-hand side. Okay, I want to isolate the x, have x on its own. So I want to have something like x equals and then everything else. So to take the 4 across, if I take it to the opposite side, the sign changes. So it becomes -4, and that goes away. The other way of looking at it is, I'll just write on the side of here, if I had x plus 4 equals 10, if I want to get rid of the 4, I would subtract this side by 4, so I've got x on its own. And since I'm doing it to the left-hand side, I must do the exact same to the right-hand side. So x plus 4 minus 4 is just x. And 10 minus 4 is 6. So therefore, x equals 6. So that's the kind of solution I get. But this is the kind of idea we want to use. All right? Let's look at another example. Let's say if I had x minus 3 equals 5. Again, I want to get rid of the 3, so to get rid of the 3, I'll add both sides by 3. So I've got x minus 3 plus 3, which leaves me with x on the left-hand side. 5 plus 3 equals 8, so therefore x equals 8. Right? And what you could do is you can substitute this back into the original to check if it works. So if I went and put it back into x, or 8 minus 3, that should equal 5. Right? So you're doing the opposite, right? Let's look at a few more. Let's say if I had 2x equals 14. So I want to get x on its own. So I want just x equals. So to get rid of the 2, I have to divide by 2. Because remember, I want to have 1 in front of the x. Because 1 times x is x. So if I'm doing that to the left-hand side, I must do the exact same to the right-hand side. Right? So what are you doing is whatever you do to the left-hand side, you do to the right-hand side. So I've got 2 divided by 2, which is x, or 2x divided by 2 is x, or 1x. And 14 divided by 2 is 7. Alright? Cool. Another example, let's say if I had x over 3 equals 4, and I want to find out what x is. So I need to get rid of this 3 down here as a denominator. So I multiply both sides by 3. Because 3x, so that becomes, oh sorry, not 3x, 3 times x, which is 3x over 3, which equals 12. And 3 over 3, that just cancels out. So I am left with x equals 12. And that is my answer right there. So this is how we solve. You're trying to solve to isolate that variable. Alright? Sometimes you might have some problems which you have to do an extra step. So sometimes you might get something like 2x minus 5 equals 11. So again, first things first, we leave the x as it is. We get rid of this 5 first. So we're going to have 2x minus 5 equals 11. We add 5 on both sides. Now we simplify. So we get 2x equals 16. Now I need to get rid of this 2, so I divide both sides by 2. So I am left with x equals 8, because 16 divided by 2 is 8. So if you think about bedmas, alright, bedmas is when you're trying to obviously simplify expressions. But when you're trying to solve and isolate something, you're doing pretty much Sam, Deb. So you're doing the reverse order. So this is to simplify and this way to solve. Alright, I'll get rid of this over here. So Sam, Deb, I'll write down the bottom here. And that's the kind of process you follow when you're doing that. So you do the subtraction, the addition, the multiplication, the division, the exponent, and then the bracket at the end. So you're doing the opposite direction. So that's the kind of idea we'll go with. Let's look at a more of a lengthier example. Maybe let's say if we had 3x minus 2 equals x plus 5. So again, we've got something with like terms. We take all our x's to one side and all our numbers or non-x's to the other side. So again, so what I'll have is I'll have 3x, and if I take this x to the other side, that becomes minus x. And if I've got 5, if I take this negative 2 to the other side, that becomes plus 2. So again, the process, I'll write the working on this side over here. If I have 3x minus 2, we're adding 2 over here. I'll put equals x, we're subtracting x over here. I'll slide across a little bit. Plus 5, right? Because we're subtracting x over here, we must subtract x on this side as well. I need a bit more space. And because we're adding 2 over there, we add 2 on this side as well. So this is the 2 added over here, and the x's subtracted over here. So whatever you do to the left hand side, you do to the right hand side. Whatever you do to the right hand side, you do to the left hand side. Alright. So that's why I just skipped that step over here. I went straight down to this. So we add and subtract our like terms. We got 3x minus x, that leaves us with 2x. We've got 5 plus 2, that leaves us with 7. And then we can divide both sides by 2 because we want to have x on its own. Therefore, x equals 7 over 2, that is 3.5, or you can leave it as 7 over 2. So that's how we solve our expression. Alright. One more example. One more. We'll go with 3 bracket 2x minus 1 minus 5x equals 6. Alright. So again, we're going to try to simplify this. We want to have all our x in the same side. So what I'll do is first I'll actually expand this bracket out. Because I want to have all the x's. Because I need to expand this out to get all my x's. So I'd have 6x minus 3 minus 5x equals 6. Now I've got like terms over here. The 6x minus 5x. So that just leaves me with x minus 3 equals 6. Alright, and now I want to get rid of this 3. So that means I've got x minus 3. I'll add 3 on this side. I've got equals 6. And I'll add 3 on this side as well. So therefore x, go back to my black color there, x equals 9. Right? And that is how I solve this expression. Right? So just remember, when you're solving expressions, you want to simplify, solve, and we're trying to isolate that x. So key thing to remember is you're trying to isolate the x.